All right, so our objective for today is I will be able to critique other students' work and revise my own work. So as I said yesterday, it was a 2-day kind of math assignment because today you're going to be looking at how other students answered the questions that you were given. You're going to look at how they answered it, and you're going to look very specifically at some things that I'm giving you. There's a lot of typing today, so I'm sorry in advance. And then you're going to look at your own work, and you're going to go, okay, did I do enough? What do I need to do to add to my work to make it more clear? So here was the original problem. How many chairs did Miss Soto set up? Here are the clues. Clue A, when there are 2 chairs in each row, there is 1 leftover chair. When there are 3 chairs in each row, there is 1 leftover chair. When there are 4 chairs in each row, there is still 1 leftover chair. When there are 5 chairs in each row, there are no leftover chairs. How many chairs do you think Miss Soto set up? Make 2 conjectures, which is guesses, which we went over yesterday. Remember, the room holds no more than 35 chairs. So you guys had 2 guesses, and first we're going to go over this student, and I'm going to go over it with you. So first one, and this student's guess was 23. So I'm actually going to write that down on my slate over here. 23. Okay. And there, so what is the child's conjecture? What is their guess for that one? I'm putting 23 chairs. What is the child's argument? So this is where the child's argument is. 23 does not work because in clue C, it says 4 chairs and 1 left over, but it has 3 left over. So let's make sure that that is accurate. So if I have 23 and I'm going in rows, they said for clue C. So let's look at clue C. It says when there are 4 chairs in each row, I have 1 leftover chair. So as I look at my hover cam, write 23 over here. When there are 4 chairs in each row, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So there are 3 chairs left over when we do rows of 4. So that student is correct. Their argument is correct. So let's go back. And it says, what is the child's argument? That it doesn't work. Is this clear or not? Well, they did exactly the same thing that I did. I would say, yes, their argument is clear. Does 23 chairs work with any other clues? Okay, so let me go back. And let's say 23, when there are 2 chairs in each row, there's 1 leftover chair. Let's try that one. So 23, 2 chairs in each row. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that means that when there are 23 chairs and there are 2 in each row, there's 1 leftover chair. So yes, clue A. And so I will write in my box, I gotta move me. Yes. Clue A. Why does this child use only 1 clue in their argument? I'm going to say because when the conjecture does not work, you only need 1 clue to prove it. So let's say 23 did work for all of these different clues. You would need to show those other clues because you're proving that it's correct. Since we're proving that this is incorrect, really you only need one clue to do it, if that makes sense. Okay, so now I've answered all the questions. Now this is your turn. Use the clues to make a mathematical argument for or against your second conjecture of 25 chairs. Show your reasoning. My second conjecture was right because of all the clues were correct. So, what is this child's conjecture? What's their guess? You would put it right here. What's their argument? Their argument is right here. Do you agree with their argument? And explain, why do you agree? Why do you disagree with their argument? What mathematical reasoning did this child use in their argument? Is there mathematical reasoning here? How can this argument be improved? So, different ways that this, when you're especially comparing between this one and that one, this one you have a visual example of showing why it doesn't work. This one doesn't have a visual example. Excuse me, I'm about to sneeze. Sorry about that. I was saying that this example doesn't have a physical example. It doesn't show me any math. It doesn't tell me why 25 chairs is correct. And it says it was correct with all of the clues, and it doesn't prove to me any of that. So that would be some reasons why this is kind of incomplete work. Okay, so what could they do to make it better? All right, next one. What is this child's conjecture? What's their guess? It's right here. What is their argument? Their argument is 15 chairs work because in clue D, it said 5 in each and none left over. And there is none left over. There you go. Do you agree with this conjecture? And the best way to figure out if you agree with this guess or not is to try it against one of the other clues. Okay, I would try this against the maybe groups of 4 and see if there's one left over. Let's try it. And so for each of these slides, I would like you to try those student guesses against those clues. Okay, so let's go with 15 chairs. Okay, and clue, I believe for the 4 in each row, it needs to be, yep, 1 left over. So let's try that with 15. I'll show you on the hover cam. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so when they're in rows of 4s, once again, we have 3 left over. So does this work for our problem? It does not. So when you go back to the slide, do you agree with this conjecture? No, because it doesn't work for all the rules. What is missing from this child's argument? What they're missing is that they need to prove it with more of the clues, okay? So since I kind of did this one for you, I'm going to go ahead and just type it in. 15, what is their argument? It works because of clue D. I'm going to say no, because it does work with clue C. More proof using different clues. Okay, and then you're going to do the next one. This student has a lot of beautiful drawings, so that way we can see a lot. So let's see. What is this child's conjecture? It's 32. What is this child's argument? 32 cannot be the number because it did not have one left over. And looks like they labeled clue A, clue B, and since these are rows of 4s, we know that this is probably clue C. Do you agree with this argument? Well, it looks like they proved it with 3 different clues, so that's good. How can this argument be improved? You tell me. You tell me what you think should be should be included in this argument. Now reflect on your work. What did the problem ask you to do? The problem asked you to make 2 guesses on how many total chairs Miss Soto set up in the room. What are some ways to show your mathematical reasoning in your argument? So some mathematical reasoning could be arrays, could be multiplication, could be, I would say that arrays would be the best way to show your work because we're talking about rows of chairs, and rows of chairs are basically arrays. So, did you use the clues to make 2 different conjectures for the number of chairs Miss Soto set up? That's a yes or no, but you'll have a lot of space to write it. Did you make a mathematical argument for each conjecture? Did you argue mathematically why your guess is either correct or incorrect? Did you use drawings, words, or numbers to make your argument clear and complete? That's either a yes or a no. What do you need to do to show that a conjecture is correct? And that is what you need to put here. What do you need to show? You need to show why it proves those clues, okay? And so the next couple of slides are your guys's guesses and your mathematical reasoning. I want you to go through and edit that and make sure that everything is nice and correct. So let's just go over one student's example. First conjecture is that Miss Soto set up 4 chairs. Now, that's interesting because when there are 5 chairs in each row, there are no leftover chairs. So we know that 4 already does not go into clue D. Second conjecture is that Miss Soto set up 5 chairs. So we can check that and see if that is correct. And it says when there are 4 chairs, there is an extra chair. There are 5 chairs. She needs 7 rows to get to 35. So I'm not really sure what they were thinking when it came to these 4 chairs. Not sure. So when there are 5 chairs, no leftovers, and you make 7 rows, you get 35. Oh, okay, now I understand. This student was confused that they thought we were talking about how many chairs are in each row, not how many chairs are total in the classroom. So it's how many chairs are total in the room, not how many chairs are in each row. But we could try this one because really though their guess is 35. And so we could actually try that and see if it works with all of our rules. So for instance, 35, let's try it against our rows of 4. They seem to be my favorite ones to work with that. $35. All right, when they're in rows of 4, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So when they're in rows of 4, I have 3 left over. And our clue is when they're in rows of 4, I have 1 left over. So we know that 35 is incorrect. And I think that this student was only using clue D as their proof. So now we know that we need to check all of each of the clues. When we have a guess for how many total chairs, we need to check each of the clues to make sure that it fits each one. All right, I am out of time. I will see you for English language arts.